tomorrow we've got a test at the very end of our angles unit. So I want to go through this video in case any of you were absent. I know we've had a kiddo on a cruise and a girl who had COVID. So this is for you too, and whoever else wants to see it. The top is our math vocabulary, and make sure you open up your notes if you're confused on these. And you'll have some notes on. It's not the notes packet from last week, it's the one from the week before. So a right angle equals 90 degrees, which is D. And this is kind of what it usually looks like. Complementary and supplementary sound the same, but if someone gives you a compliment like, your hair looks really nice today, you say, right? That's how I remember that this one is equals 90 degrees. Oh, excuse me, two angles that add up to be 90 degrees. Supplementary is going to be two angles that add up to be 180, and they could be in different locations. A lot of times I draw this picture and it looks like they're a linear pair always. And they can be in two different locations. So we've got obtuse and acute. Sometimes people will say, oh, that angle is so cute because it's less than 90 degrees. And then the obtuse ones are greater than 90 degrees, and a right angle is equal to 90 degrees. So the only one we have left is an angle that is 180 is a straight angle. Those always sounded funny to me. I feel like an angle should be bent. But an angle that is 180 degrees, just, that's it. It's the whole way around. Okay, name and classify the angle. So this number 7 is acute. That's the classification. And this number 8 is obtuse. That's its classification. And it asks for two names. There are 4 possible names. I can name this E, D, C. Or I could go the other way. I could start with the C and then go to D and E. Because there is a number here in the angle, it could be angle 3. And because there's only one angle at the vertex, I could call it angle D. It wants you to pick 2. That's where there's 2 lines. All right, similarly on number 8, you could start with SRQ. I could go the other way around, angle QRS. Because there's a number here, I could call it angle 1. And because there's only one angle at that vertex, I could call it angle R. So an example of when you can't use the vertex is right here on number 9. Can you see that there's 2 angles with vertex Q? So I wouldn't know which one you're talking about. That's why as you look over at the directions, they're using 3 letters. So I know which one they're referring to. Okay, these next 3 problems are reviewing the angle addition postulate. And it said something like, if you have a ray that cuts inside an angle, when I add these 2 up, it'll give me the whole entire measure. So PQS, this one, plus SQR will equal the whole entire angle PQR. So a lot of kids kept trying to do supplementary angles here, which is on the back of the review. This is not supplementary angles. Again, angle addition postulate. All right, let's look at the directions. Measure of PQS. You need to come over here and write that 63 degrees inside the PQS. Oh, I missed a whole line of directions. Find the measure of the specified angles, and this is so important. QS bisects, so QS is here, and it bisects this big angle, PQR, and I know that if it's an angle bisector, it cuts it into 2 equal pieces, not just 2 pieces, but 2 congruent pieces. And, okay, they want me to find some measurements. Well, if PQS is 63, and this is congruent to SQR, I can write that this is 63 degrees. And let's see, they're asking for PQR, which is that whole angle. I can use the angle addition postulate. Add those up. Okay, this one gets a little more complicated because it didn't give me a number for the measurement. It gave me an expression. Find the measure of the specified angle. It actually doesn't say an angle. It says solve for x, but anyhow. QS bisects. That word is so important. So QS is bisecting PQR, which again means these are two congruent pieces. And it has more information. PQR, so this whole entire angle, is 102 degrees. I had a lot of students set up an equation that said 10x plus 1 equals 102. No, it doesn't. The whole thing is 102, not just the little part. So there's two options. Like we did up above where we put 63 in both spots because of the bisector, we could just put 10x plus 1 in this piece. They are congruent. So I could say 10x plus 1 and add that with 10x plus 1, and it would equal the whole. Or some students cut this 102 in half. So this could be equal to 51. You could just solve it that way. Most students did this, though, I think. Combine my like terms. So the 1 and the 1 are alike, and 10x and 10x are alike. And from there, my inverse operations. Divide by 20, x equals 5. All right, one more like this. Let's write this in our picture. It's the measure of D, E, F. Okay, that's the whole entire thing is 117. Find the measure of D, E, G. Well, I'm going to have to use that angle addition postulate again. These two are not equal. 12x plus 1 and 5x minus 3 are different sized angles. But since EG is going right in the middle of them, I know that I can add them up. To 117. Again, on this one, some people were really stuck on the supplementary angles from this week's lesson, and they kept adding things at phi 180. So in angle addition postulate, there can be all kinds of different sums. Just look at the directions. All right, let's solve this by combining our like terms. 12x and 5x is 17x. 1 and a negative 3 is a negative 2. And then we can solve this algebraically. Have to be on a 17x equals 1. I didn't think that was going to go into it evenly. I was very skeptical. Okay. Well, they want more than just x equals 7. They want the measure of D, E, G. D, E, G. And they don't want me to write 12x plus 1. Well, I can take this 12, and instead of writing an x, I can plug in this 7. I better grab my answer key. I'm trying to quickly do 12 times 7 in my head. All right, 84 plus 1 is 85 degrees. That's this one. So there's two ways to find GEF. I can do the same thing that I just did to find DEG, where I can take that expression 5. Instead of the x, I'll bring down this 7, right? Minus 3. I do know 5 times 7. 35 minus 3 is that 32 degrees. Or I could have taken this whole, the 117, and subtracted 85 from it. Could have done that. Okay, use the picture to answer the questions. There's quite a few correct answers. I'll try to do as many as I can. So corresponding angles, the definition said it's two angles that are on the same side of the transversal. Here's my transversal. And in the same position. So if I'm looking at 1, 4, 5, and 8, 1 and 5 are in the same position. 4 and 8 are in the same position. If I look to the other side of the transversal, so like 2, 3, 6, and 7, 2 and 6 are in the same position, and 3 and 7. So those are corresponding. alternate interior. When I talk about things being interior or exterior, I'm now looking at the parallel lines. So the ones that are inside are 3, 4, 5, and 6. And if they're alternate, they're going to...
Teachers, just a reminder to keep your...
I don't remember what I was saying. They just did like 5 minutes worth of announcements. Alternate interior angle. Oh, I know where I was. So the interior angles are 3, 4, 5, and 6. And alternate means they're on opposite sides of the transversal. So that makes 4 and 6 alternate interior, and 5 and 3 alternate interior. Alternate exterior, as you might be thinking, are again on opposite sides of the transversal, but they're outside of my pink parallel lines. So 1 and 7, 2 and 8. A lot of students forgot what adjacent angles are. So adjacent angles share a common ray. So if I look here at angle 1 and angle 2, do you see how they share this ray? So there's tons of these, 1 and 2, 2 and 3, 3 and 4, 4 and 1. And if I come down to these bottom 4, 5 and 6, 6 and 7, 7 and 8, 8 and 5. But they share a common ray. Vertical angles are opposite each other. They are a reflection. So there's quite a few sets. If I start at the top, 2 and 4, 1 and 3. If I go down to the bottom, 5 and 7. And these are congruent. We use these all the time down below on these problems. All right, consecutive same side interior. It's so self-explanatory. They're interior, so our options are 3, 4, 5, and 6, but they're on the same side. They're consecutive. So we've got 4 and 5, 4, 3, and 6. Some students, when they did this, they didn't understand that these lines were for a pair, so they were writing things like 4 and 5, and then they were only giving me one set. And it is, I believe each line is for its own set. Okay. Oh, the joy. The first thing you need to do when you see a diagram like this is put in the information right on the picture. So the measure of angle 2 is 125. The measure of angle 12 is 37. And the measure of angle 18 is 102. Okay, there is way too much to digest this all at once. So my suggestion is try to focus on one piece at a time. See if I can get myself a square. Sorry, I probably should have done this ahead of time. Okay, I'm going to move this guy. So let me move it. I'm going to move him and try to cover up the stuff that we're just not using right now. Okay, let's not worry about that for a minute. Let's just look at these 4 angles, 1, 2, 6, and 5. Vertical angles. If you have not trained your eye to notice vertical angles, now is the time. They are congruent. They are a reflection. So if I reflect angle 2 over, I get angle 5 is also 125. And the next thing your eye needs to notice is these linear pairs. So here is a straight line. Angle 1 and angle 2 make a linear pair. They'll equal 180. So if you subtract those two, if you take the whole thing, the 180, and you subtract the part that we know, it'll give you this unknown piece. So 1 and 6. Okay, I'm going to move this square. We're just going to focus on this one transversal here. Oh no. People are going to come in for lunch. Okay, so I'm looking and I've got X angles and O angles. So if I follow this transversal down, like my eyes are following it down. I've got X angles and O angles. So 10 and 16 are also 55. 15 is 125. And I can find 11 because I can take the 125 and minus 37. The 37 came from the given. Okay, so I filled in all that I can there. Now, oh, it's not going to let me cover stuff up very well. Now I'm going to come over here and look at 13, 14, 17, 18. I have vertical again. And I've got these linear pairs. So 180 minus 102 is 78. Vertical, 78. X's and O's, 78. X's and O's, 102. X's and O's, 102. So the only ones I have left now are angle 7 and angle 8. A couple people noticed that, I don't even know, angle 12 and angle 7 are alternate interior. If you don't notice that, you have to look at the triangles. So 180 minus 102 minus 37 will give me angle 8. I don't know how loud that is, sorry. I believe that's 65. Angle 8 is 65. So I lost track of writing them over here. But I've got them all, and you would transfer them into these lines. Okay, here's the quick part. And the strategy is you just focus on one transversal at a time, so don't worry about this down here. Vertical angles. Supplementary angles. Follow this transversal. My X's and my O's. Okay, now I can focus over here. Vertical angles. Supplementary, so 180 minus 120. Vertical angles. Corresponding, corresponding, vertical, vertical.